Revit Slanted and Tapered Walls, Differences, Use Cases, and Modeling Workflow. Hello and welcome to our new video. In this video, we will talk about slanted and tapered walls. Let's begin. We use a slanted wall when we want the entire wall to tilt at a specific angle. This is common in modern facades, attic walls, or when a wall follows a roof structure. In this case, the entire wall section tilts as one rigid geometry. We use a tapered wall when we want only one layer of the wall to have variable thickness, while the other layers remain defined. This is especially useful in facade systems, insulation layers with variable thickness, or constructions where the wall width is controlled at the top or at the base. So, slanted changes the angle of the entire wall, while tapered changes only the variable layer inside the wall. First, we will talk about slanted walls. Let's start by drawing a wall. We will select this wall type. We will also create sections so we can better see what is happening. We will turn off crop view and crop region visible. We will switch the detail level to fine. When we select the wall, in the Properties panel we go to Cross-Section Definition. We can see that it is currently set to vertical. In cross-section definition, we can choose between vertical, slanted, and tapered. When we select slanted, we can see that the angle from vertical parameter appears. The angle can be changed in the Properties panel, but also by clicking on the top control of the wall. We will set it to 25. This is how it looks in 3D. Now we will type -15 and again check how it looks in the 3D view. Now we will add windows. We can see that the windows are placed vertically, even though the wall is slanted. But this can be corrected. We will select both windows and in Properties, under Constraints, Orientation, instead of vertical, we will choose slanted. Now we can see that the windows are aligned with the wall. Now let's place a door. We can see the same situation as with the windows. The door is placed vertically. While it is selected, we go to Properties and under Orientation we change it to slanted. The door will now follow the wall angle. We go to the section view and switch to wireframe. We can see that the door is under the same angle as the wall. We will slightly move the section so that it cuts directly through the door. However, in practice, doors almost always remain vertical, even when the wall is slanted, due to structural and functional reasons. We will return it to vertical. We will solve this in a different way. We go to the floor plan and select a wall. We will choose this generic wall type. On both sides of the door, we will draw an additional wall segment. Now we go to the 3D view. We return to the floor plan and slightly extend the walls, then go back to 3D. We select the wall and go to Edit Profile. We will use the Pick Lines tool to reference the edges of the opening and close the gap that was created between the vertical door and the slanted wall. We will do the same with the second wall we created. Of course, we can slightly adjust them and use a line if necessary. This is the result. We can also add a roof above. It is important to mention that with slanted walls, we can edit the wall profile. Now let's test whether a curtain wall can be slanted. First, we draw it. Then we change it to slanted and set the angle to -25. We can see that it works and how it looks. We will switch to shaded view. Let's also test a stacked wall. We draw it, select it, and change it to slanted. We will set it to -10. Now we will move on to the tapered wall. We repeat the process. We select the same wall type as before and draw it. We create a section view. Again, we turn off crop view and crop region visible and switch to fine detail level. We select the wall and try to change it to tapered. We receive a message. The message appears because none of the wall layers has the variable parameter enabled, which is required for a tapered wall. We go to Edit Type, then Edit Structure. We can see the variable column with checkboxes for each layer. For the layer we want to be variable, we check its box. It is important to note that only one layer can be set as variable. In this case, we will select the structure layer. After setting one layer as variable, we can see in the settings the cross-section definition parameters, including default exterior angle, default interior angle, and width measured at. When we open it, we see the options top, base, and bottom. For now, we will leave it as it is and return to it later. We click OK. Now we change the wall to tapered. We can see that the error no longer appears. In the Properties panel, we now have exterior angle and interior angle, but they are currently grayed out. We go again to Edit Type. For the exterior angle, we enter 5, and for the interior angle 15. We click Apply, then OK. We can see that the wall has been created with the angles we entered. We can also change the angles in the lower Properties panel for the selected wall. We will try changing it to 7. We receive a warning. This happens because we define the angles in the type properties, but we did not enable angle overrides in the instance properties. It is important to understand the difference between type and instance parameters. Type properties define the default angles for all instances of that wall type in the project. Instance parameters apply only to the selected wall. The Enable Angle Overrides option allows a single wall instance to have different angles from those defined in the type properties. We click Cancel, then Cancel again. We enable the Enable Angle Overrides checkbox. Now we try again to change the angle to 7. This time it works. Let's set it to 11. This is how it looks in the 3D view. We switch to shaded. When we select a wall and choose tapered, and check the available wall types, we can see that only one type is available. If we switch back to vertical, we see multiple types. This is because only one wall type currently has a variable layer enabled. The others do not, so they are not available for tapered. Now we will set a variable layer for a few additional wall types. For example, this wall type. And also this one. Now we select tapered again. We can see that we now have 3 wall types available. When we select this wall type, we see that the default angle values are 0, because that is how they are set in the type properties. We will select the exterior wall type that we used previously. We can see that the angles are automatically 5 and 15. We draw a wall. This is how it looks. When we select the previously drawn wall where we enabled angle overrides, we can see that its angles are 11 and 15. Now we select the last wall we drew and go to Edit Type. We change the interior angle to 20 and click Apply. We can see that only this wall changed. The wall with overridden angles did not change because it is controlled by its instance override. We will delete this last wall. Type properties affect all walls of the same type in the project. Instance parameters affect only the selected wall. If we change a value in type properties, the change applies to all instances of that type. If we change a value in instance properties, only that specific wall changes. Now we go to the section view. We change the interior angle to 0 degrees and the exterior angle to 2 degrees. We slightly lower the wall. We go to Edit Type and also change the exterior angle to 2 and the interior angle to 0. We click Apply. Now we go to Edit Structure and change the thickness of the variable layer to 20. We click OK, then Apply. Width measured at is currently set to top. We click OK. We dimension this layer. We can see that its width is 20. That means that at the top of the wall, the layer thickness is 20, which is the value defined in the wall structure. We go again to Edit Type and change width measured at to base. Then click Apply. Now we can see that at the top the width is 5. We slightly extend the wall downward. Now we can see that the width of 20 is at the base of the wall, at the starting level. We go again to Edit Type and change width measured at to bottom. We click Apply and OK. We measure again the layer thickness at the bottom of the wall. We can see that it is 20. So when we change width measured at between top, base, and bottom, we control where the defined thickness of 20 is applied along the height of the wall. We will set it back to top. Click Apply, then OK. Now we go to the 3D view. We change the exterior angle to 3. Then to 5. Now let's place windows. We will select a double hung window and place 2 windows. We can see that they are placed vertically. We select both windows and change the orientation. One of the options is Slant Along Exterior. We select it and click Apply. We go to the section view and switch to wireframe. We can see how the window is positioned. Now we select both windows again and choose Slant Along Interior. We change the interior angle in the Properties panel to 3. We can see how the window adapts to it. Now we change the exterior angle to 7. We select all windows again and choose Slant Along Exterior once more. Now we add a door. It is placed vertically, but we can change that. First, we choose Slant Along Exterior. Then Slant Along Interior. We observe how it looks in section. Finally, we return it to vertical orientation, as that is typically the case in practice. Now we draw a curtain wall and a stacked wall to test the tapered option. We select a curtain wall and try to change it to tapered. We receive a warning that curtain and stacked walls cannot be tapered. Curtain and stacked walls do not support the tapered option because they do not have a traditional layered structure with a variable layer. If we go to Edit Type, we can see that there is no variable layer option available. The same happens with a stacked wall. When we try to change it to tapered, we receive the same message. In Edit Type, we can see that there is no variable layer parameter. Understanding the difference between slanted and tapered walls is essential because it affects the wall structure, documentation, opening behavior, and dimension control. A slanted wall modifies the entire wall section as rigid geometry, while a tapered wall modifies only the variable layer, which is particularly important in facade systems and structural analysis. We hope this tutorial helps you improve your Revit workflow. If you have any questions, feel free to leave them in comments. Don't forget to like, share, and subscribe for more tutorials.